What if everything you thought about space colonization was wrong? Most people would say Mars is the future home of humanity. Red rocks, dust storms, and dreams of Elon Musk. But what if I told you there's another option, and it might actually be better? Yes, I'm talking about Venus. Surprisingly, this scorching hot planet may have a better atmosphere and gentler gravity than Mars. That's right. Despite all the hype around Mars, Venus might be the dark horse in this interplanetary race. So, let's dive in and figure out once and for all, which planet is truly better for human colonization. Sure, Mars looks like a logical choice. It has a solid surface, some water, and a reputation for being Earth's future backup drive. Venus, on the other hand, gets dismissed as a fiery hellhole. But here's the twist. Venus actually has an Earth-like atmosphere, just much higher up, and gravity that's way closer to what we're used to. So today we're going to break it all down. We'll compare both planets across 5 key categories to figure out where we should really build humanity's second home. Mars versus Venus. Let's get started by learning a bit more about our two rocky neighbors. Mars has been the focus of space agencies for over 60 years. Astrobiologists have been obsessed with the idea of sending humans there. Yet, despite all that time and planning, no human has set foot on its red soil. NASA says a crewed mission could happen sometime in the 2030s. That's still a ways off. Now let's swing our telescope toward Venus. It's got the nickname the Hell Planet, and honestly it earned it. Surface temperatures are high enough to melt lead. But, surprisingly, 50 kilometers above the surface, the atmosphere becomes far more welcoming. That's the part people forget. Just 50 kilometers above Venus's surface, the air pressure is similar to Earth's. Gravity there is about 90% of what we feel here. In comparison, Mars only gives you about 38% gravity. That's a huge difference when thinking long-term. Now Mars is about 280 million kilometers away from us, and we've confirmed that water once flowed on its surface. But Mars is small, only half the size of Earth. That could cause issues when it comes to supporting a large population over generations. Venus, on the other hand, is nearly the same size as Earth. Even better, Venus is a bit closer to Earth than Mars. It's about 260 million kilometers away, so traveling there could be quicker and more efficient. And while its thick cloud cover is terrifying on the surface, those clouds could actually help. They provide protection from solar radiation. Plus, with gravity nearly matching Earth's, we'd likely have an easier time adapting. Alright, now that we've met both planets, it's time to put them head to head. We'll start with something basic but crucial. Where would we actually live on each planet? Housing is the first major hurdle. Back in 2010, NASA launched something called the 3D Printed Habitat Challenge. The goal? Create sustainable housing designs for Mars. Dozens of teams submitted innovative concepts, and the result was a library of creative ideas for how humans might survive there. But Mars has a big problem: its atmosphere. It's made up of 96% carbon dioxide. Breathing there would be impossible without constant life support. Oxygen would have to come from your suit or carefully managed life systems. And then there's the gravity issue. With only 1/3 of Earth's gravity, walking might feel more like hopping. Now that might sound fun at first, like living on a trampoline. But low gravity comes with physical consequences. Over time, our muscles and bones could weaken. Still, researchers are optimistic. They've explored the idea of using Martian resources to build habitats. That means no need to haul materials all the way from Earth. Transporting cargo between planets is expensive and slow. A single trip back and forth takes around 9 months. That's not ideal if you forgot your screwdriver. So scientists propose using local materials, like iron, nickel, and sulfur, found on Mars to build everything from homes to research stations. During the 3D Habitat contest, one team stood out with an automated design made entirely using 3D printing. The structure was built from natural, biodegradable Martian resources. This approach could be our best bet, since there won't be many humans available to help build it first. Automation is key. One of the standout designs was called Martia. It's tall and slim, built from basalt composite, which is both sturdy and eco-friendly. Inside there are 4 levels including a kitchen, sleeping quarters, and space to relax. It's like a futuristic tiny house, but on another planet. But not everyone thinks we'll live in towers. Some researchers suggest building underground homes on Mars. Others have proposed igloo-style habitats. Living below the surface could protect us from radiation and extreme temperatures. But let's be honest, it wouldn't be very comfortable. Imagine living in a dark, windowless cave where you can't even breathe the air. That's what it could feel like. It might be necessary, but it would definitely take a toll on your mental health. And while we're talking about isolation and survival, let me tell you a quick story that hits close to home. A friend of mine, Jamie, felt stuck for months, burned out at work, uninspired, and unsure what to do next. Then he signed up for coaching through strawberry.me and it changed everything. Seriously, the transformation was wild. That's why we've partnered with strawberry.me so you can try it too. Just sign up, take a quick quiz about your goals, and you'll get matched with a certified coach. You can read reviews, check bios, and even message your coach before your first session. They won't just give advice, they'll help you make real changes and hold you accountable. So if you're ready to build confidence, break old habits, or just take better control of your future, this is the place to start. Go to strawberry.me/whatif, take the quiz, and find the right coach for you. Trust me, you won't regret investing in yourself. Now let's leave Mars behind and see how things compare on Venus. We already know the surface is a nightmare. The heat is unbearable. But 50 kilometers up? Things start to look much better. That's where we'd build our homes. Temperatures would still be high, between 30 and 70 degrees Celsius, but manageable with cooling systems. Instead of buildings on the ground, we'd build floating cities in the sky. That's not science fiction, it's one of NASA's actual concepts. It's called HAVOC, or High Altitude Venus Operational Concept. Basically, think of massive airships floating in Venus's upper atmosphere. These blimp-like structures would act as homes, labs, and workspaces. Because of the thick Venusian air, the ships could float with relative ease. We'd need materials resistant to sulfuric acid, and definitely some solid air conditioning systems, but it's possible. The idea is to create an entire community suspended high above the planet's dangerous surface. People would never step foot on Venus's ground. Instead, the surface would be reserved for research only. Buildings, roads, and cities would exist entirely in the sky. It's a bold vision. The HAVOC would launch in a compressed state. Once it enters Venus's atmosphere, a parachute would deploy. The airship would then inflate and begin to float. Materials on Venus, like iron, nickel, titanium, and aluminum, could be harvested for construction. But because the planet is so hot, we'd need temperature-resistant tools and machines to collect and process these resources. Engineers would have to build robots that can handle the heat. This could be a slow and difficult process. Setting up safe and usable resources on another planet won't happen overnight. It could take months, or even longer, before we reach a point where those resources are reliable and safe for daily use. That's assuming everything goes smoothly. When it comes to actually building homes and living spaces, though, Mars clearly has a lead over Venus. With its solid ground and slightly more manageable environment, Mars makes the idea of long-term settlements far more realistic compared to floating cities suspended in Venus's toxic skies. Now let's talk about the next big problem, food. Once you've got a home, you'll need something to eat. And the first brave explorers on Mars or Venus better be ready for a serious diet change. You won't be having burgers or ice cream in space. The truth is, while there might be food, your options will be extremely limited compared to what you're used to back on Earth. There are no sprawling farms, no factories making your favorite snacks, and definitely no corner grocery stores. Say goodbye to meat and dairy. Space life means plant-based is the way to go. A sustainable diet on another planet would rely almost entirely on fresh fruits, vegetables, seeds, and nuts. Luckily, we found evidence of water on Mars. That gives us a huge advantage. With that water, we can start growing crops in controlled environments like greenhouses. Interestingly, we might even need less water to farm than we do here on Earth. Thanks to Mars' lower gravity, just 38% of Earth's, its soil would hold onto moisture longer, meaning we won't need to constantly water plants like we do at home. But there are some big hurdles too. Mars has very little oxygen and it's bitterly cold. That means Earth-native plants wouldn't survive on their own. We'd need to recreate an Earth-like environment inside greenhouses, controlling the temperature, air composition, and even light exposure. Scientists may also need to genetically modify plants to help them survive in Martian conditions. Our food sources would be a mix of freshly grown produce and prepackaged goods brought from Earth. Things like canned beans or dry pasta. And if you're craving meat, maybe pack some beef jerky, though you'll run out of that pretty fast. That stuff will disappear in no time. Now Venus is a bit of a different case. If we're going with the floating city idea, then the extreme surface temperature of Venus, hot enough to melt lead, won't be an issue for growing food. We'll be floating above it all. But there's a catch: acid rain. We'd have to build everything to withstand that. The bigger problem, though, is that there's no confirmed water on Venus. To grow food, we'd need to use greenhouses again, but we'd also have to produce water from scratch. Sounds like science fiction, but it's possible, with the right tools and technology. To create water, you just need 2 hydrogen atoms and 1 oxygen atom. When they bond together, they make H2O, basic water. First, you apply heat to break apart the atoms, then allow them to rebond. While the process is theoretically simple, producing water on a large scale is still a major challenge. Right now, we don't have the tech to do it efficiently in bulk. But maybe by the time humans reach Venus, we'll have cracked the code. Like Mars, Venus settlers would depend heavily on lab-grown and greenhouse-grown foods. Think leafy greens, root vegetables, and non-perishable items. However, despite the lack of natural water, Venus does have one edge. Thanks to its proximity to the sun and knowledge we're gaining about synthetic water creation, growing food there might actually become more reliable in the long term. If we figure out how to make water consistently and safely, then Venus might take the win in this round. Between sunlight abundance and controlled greenhouse environments, we could grow crops year-round, assuming we can keep the acid rain and other environmental hazards at bay. So, surprisingly, Venus edges out Mars here when it comes to food production potential. Now let's talk about something equally important: resources. Both Mars and Venus are rich in raw materials that could be extremely useful for survival and development. Mars is loaded with elements like iron, nickel, and sulfur. Iron, of course, is essential for construction, whether it's building habitats, vehicles, or tools. Sulfur can be used in manufacturing batteries, which are crucial for storing energy in space. And nickel? Well, beyond being useful for industrial purposes, it could even help us build an economy, literally. Imagine using nickel coins as currency in a future Martian marketplace. If Mars becomes heavily populated in the coming centuries, setting up a currency system using available elements isn't a crazy idea. You'd go from bartering to banking right there on another world. Over time, a Martian economy could emerge, complete with mining industries, markets, and maybe even Martian stock exchanges. Venus also has a wealth of elements, including titanium and aluminum, both crucial for aerospace construction. Since we can't live on the surface of Venus, everything would need to be built in the sky. Airships, floating homes, and transportation vehicles made from these lightweight, durable metals. Another valuable element found on Venus is silicon, not to be confused with silicone used in cosmetics. Silicon is a key component in solar panels, which is great news because Venus gets a ton of sunlight. We could harness that energy to power our floating cities. Solar panels also work well even in cloudy conditions, and since Venus has a thick, cloudy atmosphere, they'd still function efficiently. They would also eliminate the need to build complex power grids and plants, which would be a nightmare in Venus's hostile environment. So yes, power would be cleaner, simpler, and more reliable, assuming the panels hold up. But it's not all sunshine. Traditional electricity infrastructure on Venus would be a huge risk. Any system failure or blackout could quickly turn deadly in such an extreme environment. Unlike Earth, where a power outage is just inconvenient, on Venus, it could shut down life support systems and endanger lives. That said, solar energy gives us a safer alternative. So when it comes to raw materials and their usefulness, Venus wins this round. Its access to lightweight metals and its solar potential make it an ideal location for a floating, solar-powered civilization in the sky. Now the big question: can we actually move to these planets? We've talked about food, homes, and resources, but what's the bigger picture? Which of these two worlds is more practical for humans to settle on in the near future? The answer, for now, is Mars. NASA and other space agencies have made Mars their top priority. Since the 1970s, we've successfully landed several spacecraft on the Red Planet. And within the next decade, most likely the 2030s, humans are expected to make their first landing after years of studying and testing. Venus has also been studied, but mostly by robotic missions. The surface is so hot and hostile that it's rarely considered a real option for human life. After all, what's the point of colonizing a planet if you can't live on it directly? Mars is different. We've explored its surface extensively. NASA has even designed a Mars habitat simulator here on Earth, where 4 volunteers will live in isolation for a year to mimic life on the planet. Their mental and physical health will be monitored closely to help us understand what long-term missions to Mars might look like. Venus, on the other hand, is still more of a theoretical project. Floating cities sound fascinating, but they haven't been tested or proven feasible yet. From a purely logical and technological standpoint, Mars is the more realistic option for building a permanent human settlement. It's been researched more deeply, has had more successful missions, and already has plans in motion for human arrival. That gives Mars a solid head start. But let's imagine a future 100 years from now where humans live on both planets. What would life look like in the long run? With advances in space technology, we may eventually be able to terraform planets, essentially transforming their environments to make them more Earth-like. If that happens, Mars could become more habitable. Over generations, humans might adapt physically and mentally to Martian conditions. New generations born on Mars may never have seen Earth. Their bodies could evolve to handle the lower gravity. Their lungs might adjust to different oxygen levels. And Mars could start to feel like home, a sustainable, Earth-like planet shaped by both technology and time. Our understanding of climate change would also help prevent us from repeating Earth's environmental mistakes. Venus, if terraformed, would be a beautiful place. With its long solar days, one lasting over 100 Earth days, you could live life in a whole new rhythm. No more rushing to beat the clock. The environment might feel like an eternal summer. No curfews, no standard work hours, just long, slow cycles of daylight and night. But there's one massive downside. In about 7 billion years, the Sun is predicted to explode in a supernova-like event. Because Venus is so close to the Sun, it will be one of the first planets to be wiped out by the chaos. Mars would eventually be affected too, but its distance from the Sun means it might hold out a little longer. Maybe just long enough for humanity to escape to another solar system. So while Venus has some long-term beauty, Mars once again edges ahead when it comes to long-term survival. In the end, when we weigh everything, housing, food, resources, technology, and future potential, Mars takes the crown in the battle of planetary colonization. It may not be perfect, but it's our best shot at building a new home beyond Earth.